What's going on, guys? Welcome to your second tutorial on matrices. And in case you already noticed, yes, this is the reloaded version of matrices. So guys, yeah, where I left you was on equality of matrices. It's a pretty easy topic, and I'm really sorry now that I was doing it last night and I was really tired. So guys, again, let's start off with types of matrices. So we're gonna do the types of matrices so that you're familiar with the different types of matrices, because we're going to be using a lot of short forms for them later in this chapter. I think I'll only need one more tutorial on matrices because I just need to cover operations on addition, subtraction, and multiplication. Alright guys, so for now let's start with types of matrices. They're very easy. I'm referring to M. Agarwal 2012 textbook. So guys, he's only given 5 matrices in my book, so I'm just going to be doing those 5 with you since we're only going to be studying the exam syllabus. Alright guys, the first matrix is a row matrix. This is extremely easy. Alright guys, a row matrix is a matrix that has one row. It's as simple as that. Right? So if I have a matrix like 1, 2, 3, can you tell me its order? Its order is always R by C, row by column. So how many rows does this have? It has 1 row, guys. How many columns does it have? It has 3 columns. So guys, its order is 1 by 3, and since it has only 1 row, it is called as a row matrix. This is really easy, and I'm pretty sure you got this. So similarly, you can figure out some other examples for yourself. Next, we come on to column matrices. Now, just the opposite, not even the opposite, but just the same concept. A matrix having only 1 row, guys, is known as a column matrix. So if I have a matrix and it has elements 1, 2, 3, its order, as you might have already guessed correctly, is 3 by 1, since it has 1, 2, 3 rows and only 1 column. Now these arrows are only for your reference, guys. Alright, so this is a column matrix which is only one column, and this was a row matrix which had only 1 row. Next, I'm just going to clear this content. Next, guys, we come on to square matrix. Right, so this is the third one, and it's called as a square matrix. Very, very, very easy. This square matrix is basic of the basic. So guys, if the number of rows NO of rows equal the NO of columns, that's if the number of rows equal the number of columns in a matrix, that particular matrix is known to be a square matrix. So guys, this right here is the necessary condition for a square matrix. In a square matrix, the number of rows equals the number of columns. For an example, I'm going to give you a very easy example. Let's take a 3 by 3 matrix, okay? R, C, right? Rows by columns. So a pretty easy example is -5, 6, 9, 2, 4, 3, 6, 2, 10. Don't get confused with the minus sign. If you've seen this for the first time, guys, as I told you earlier, a matrix can have any entry, any element, anything you want to put in there, right? Because here is my matrix. It's got 3 rows and 3 columns, and this is as simple as it is. It is a square matrix. Alright guys, so this will be called a square matrix. Again, just a recapitulation, square matrix is a matrix if the number of rows of the particular matrix equals the number of columns of the same matrix. So guys, now we move on to our fourth type of matrix, and it's called the zero or the null matrix. I'm pretty sure you know what null is. Fourth type of matrix, it's called a zero, ZERO, or the ULL, or the null matrix. Now guys, a null matrix or a zero matrix is a matrix which has its elements as zero. As simple as that. So guys, this matrix, let it be named Z, 0 Z, yeah. So, and its order is 2 by 2. So it's a zero matrix, guys, because it has all elements as 0. Now you may have any matrix of any order, 1 into 2, 1 by 2, 2 by 2, 3 by 2, 69 by 29. Oh my god, I'm gonna go crazy. 5 by 4, 6 by 2, anything at all which has its elements, all of its elements as 0 and nothing else is called a zero or a null matrix. Pretty easy, huh? So let's go on to the fifth type of matrix now. So which ones have we done so far? We've done row, we've done col, I'm just going to write col, we've done square, we've done SQUARE, and we've done, so these are the ones which we've done so far. Now we come on to the last type of matrix, and that is this is actually the most important matrix in your course, because you are often you're often given questions on this. So guys, just remember this letter. It is extremely important, this letter here in your matrices chapter. I'm really sorry. It's called the identity matrix. Okay, now this is an I, although I've circled it. Identity, like you have identity cards in your school. Anyway, so we've got an identity or a unit, UNIT, or a unit matrix. Now guys, this is the most important matrix in your course, and so an identity matrix has a couple of properties which you must remember. That's number one. Let me change colors. So the identity unit matrix's first property is that it's always, guys, a square matrix, right? I don't know, I don't think I've told you this, but guys, if I have a matrix like A, B, C, D, right? Guys, this is what is called the diagonal of a matrix, and it has only one and one diagonal, which is this. Starts from top left, ends at the bottom right, and it's also called the principal diagonal. So it's called the principal diagonal, and whenever we mention diagonal anywhere in the matrices chapter, we mean top left, bottom right. Okay, so it's this is your principal diagonal or just diagonal. So guys, an identity matrix is a square matrix. That's the first property. Second property is that its diagonal elements, which I mean this element, and so on. If it is an order, if it is of a higher order, so on and so forth till the last element, till the bottom right element. So all these elements are one. Okay, so now let me take the example of an identity matrix, since now you know what principal diagonal elements mean, or what just diagonal elements mean in a matrix. Guys, you do understand that if these are the diagonal elements, then the rest, like B and C here, or so on, if I have a third row and a third column, then the other elements which are not lying on this straight line running from top left to bottom right are the non-diagonal elements, right? So these are the diagonal elements, and the rest are just non-diagonal elements. So guys, an identity matrix is a square matrix, has its diagonal elements as 1 and only 1, guys. This is 1. And another property, another subdivision is that the non-diagonal elements are 0. Right? Here. Guys, let me erase this for now, since I'm guessing you understood what my point was. Right. So I'm just gonna give you an example of an identity matrix. Some of you already must have figured it out. Pretty easy, pretty easy, pretty easy. Here. Whoa. Let me make a big one. Right. So if I have a 3 by 3 matrix, 1, 2, 3. God, I'm gone wrong. Sorry. Now this, guys, is an identity matrix. So A, it's going to be of the order 3 by 3. That's my wish, because I want an identity matrix, and I know that the first condition is that it has to be a square matrix. Now these are not these are mandatory conditions, guys. You can't just let them be. So first condition is square matrix, 3 by 3, 3 columns like this and 3 rows like this. Diagonal elements, these elements have to be 1. Non-diagonal elements have to be 0. So 1, 0, 0, 0, 1, 1. Gone wrong again there. 0, 1, 0, guys. Sorry, I'm really sorry. 0, 0, 1. So there you go. There is what you have, an identity matrix. It is a square matrix. Its diagonal elements are 1. It's all other non-diagonal elements. Here you got red. Paint all over you. Zeros. It's all other non-diagonal elements are 0. Here is what is an identity matrix, guys. So we've done the last type of matrix. That's the identity matrix, and through with this portion through with this portion too. Yes. So now let's move on to, in this particular segment or a video, whatever you might want to call it. Alright. Now let's just move on to first. I'm just going to be doing properties, or a better word would be operations. Operations. Pretty easy word, pretty easy concept. The first one that we're doing is add, addition. It's addition. And subtraction. Alright, guys, this is a very, very, very easy concept. This is the first operation, and suppose I have a matrix 1, 2, 3, 4, guys, order 2 by 2, another matrix 5, 6, 7, 8, another matrix 2 by 2. Question, first part, add A, B. Okay, this is the question. Answer: 6, 8, 10, 12, 10 on 10. Alright? Now guys, if you've already figured out what I've done, then great, because what I've done is 1 plus 5, 6, 2 plus 6, 8, 3 plus 7, 10, 4 plus 8 is 12. So guys, this is very easy. You just added two matrices One thing you have to keep in mind is you can only add two matrices if their orders are the same. Suppose if you have another matrix, say C, which equals 5, 6, 7, and another matrix which is, same matrix having another row 2, 3, 2, 3, 9. Question says add A plus C. You're right, not possible, guys. This has an order of what is 2 by 3. A has an order of 2 by 2. Even if one doesn't match, addition is not possible. So guys, A plus C is not possible, B plus C is not possible, A plus B or B plus A, both same thing are possible. Alright guys, same way, I'm just gonna have to rush through this. If the question tells me, oops, then now let me just make an Q, P since I erased them. Alright, question, subtract, find Q minus P. Answer, in terms of let the matrix be T. So I say T equals Q minus P. First one. See, again, it's possible. Both addition and subtraction are only possible if the orders are same. So I say yes, it is possible. And so I find out Q minus P. 5 minus 1, 4. 6 minus 2, 4. 7 minus 3, 4. 8 minus 4, 4. Alright, so guys, this is what Q minus P would look like. Now, what I've done is 5 minus 1, 4, 6 minus 2, 4. Again, for you guys who haven't understood, 7 minus 3, 4, and 8 minus 4, 4. Again, the answer would be the same order, guys. Again, this is again a property. I'm not going to be telling you to cram it up. This is really simple. You should understand it. So if the order is 3 by 3, or 3 by 4, and 3 by 4 again, the answer will be 3 by 4 order of the matrix, right? So guys, that's pretty much it on addition and subtraction of matrices. I will be signing off now. I'm really sorry, I made some very stupid grammatical mistakes in my tutorial. So guys, I will be going now, and one last tutorial on scalar multiplication. That's pretty much multiplication. So see you.